This tiny coding problem looks easy, but there's a trap. Watch this number, 584. Why is its waviness 2?
It has a peak and a valley. Want full solution? Check this video.
Hi everyone and welcome back. Today we are going to solve the lead code problem, total waviness of number in range number 1. Let's start by understanding exactly what the problem is asking. We are given two integers num1 and num2, and our task is to calculate the total waviness of every number in this range. But what does waviness mean? A digit contributes to waviness if it is either a peak or a valley. A peak means a digit is greater than both of its neighbors, and a valley means that a digit is smaller than both of its neighboring digits. So let's look at an example. Imagine that you have the number 5, 8, 3, 4. The digits are 5 and 8 and 3 and 4. We only consider digits that have both a left neighbor and a right neighbor. So in this case, we have to consider the numbers 8 and 3. Excuse me. So let's start with digit 8. Its neighbors are 5 and 3. And as you can see, as 8 is greater than both 5 and 3, then 8 is a peak. So that contributes 1 to our answer. And now let's look at the digit 3. Its neighbor is 8 and 4. So again, as you can see, 3 is smaller than both neighbors, so it is a value. So 3 is a value. And this also contribute another 1 to our answer. So this number contribute with 2 to our answer. So let's see another example. Imagine that you have the number 1, 2, 3, 4. Again, our candidate is 2 and 3 because they have left neighbor and right neighbor. So let's examine first the 2, the digit 2. Its neighbor is 1 and 3. It's not greater than both neighbors and it is not smaller than both neighbors. So its contribution is 0. So now let's look at digit 3. And again, its neighbors are 2 and 4, and it is neither a peak nor a valley. So the total waviness or contribution of this number is 0. Now that we understand the definition, let's think about the solution. The most straightforward approach here is brute force. So we simply iterate over the number in the range from num1 to num2, and for each number we calculate its waviness. Then we add that value to our answer. So let's look at the code. First, we will create an integer. Let's call it answer and initialize it to 0. This variable will store the total waviness across the entire range. Next, we loop from num1 to num2. So for int I equal num1 and I is less than or equal num2 and plus plus I. Then for every number, we convert it into a string. Why a string? Because accessing individual digits becomes very easy. So we will define string, let's call it num_str, and that will be the conversion of the digit to string. Next, we need to examine every middle digit. Notice that the first digit cannot be a peak or a valley because it has no left neighbor, and similarly, the last digit cannot be a peak or valley because it has no right neighbor. Therefore, we start from index 1 and stop at the string length -2. So we will loop for int j equal 1 and j is less than the num_str dot length -1 and plus plus j. Now let's focus on a single digit. Suppose we are examining the digit at position j. We compare it with the digit on the left and we compare it with the digit on the right. So if we have now two conditions, the first one, we compare the num_str at position j and check if first if it's a peak. So if it's greater than num_string of j -1 and num_string +1. This is the condition for the peak. Now we will check for the valley. It's the same condition, but instead of greater than, we check if it is less than. And if either condition is true, we increment our answer by 1. And finally, we here return our answer. So let's run it. Let's submit it. And as you can see, the brute force solution here is accepted for this problem, although it is not the best solution for this problem. There's another approach using dynamic programming, but it's much longer to explain. Maybe I'll explain it in another video. So now let's analyze the complexity. If we say that we have n to be the range size, and if for every number in this range we process all of its digits, so we will say that d is the number of digits. So the overall complexity will be O of d multiplied by n. So for the constraints of this problem, this brute force solution is sufficient and easy to implement. The space complexity is constant, O of 1. excluding the temporary string representation, and that is the entire solution. Sometimes the simplest approach is the best approach, especially when the constraint allow it. If you found this explanation helpful, make sure to like the video, subscribe to the channel, and let me know in the comments which lead code challenge you would like to see next. Thanks for watching, and I'll see you in next video. Bye.